In the land of dawn, the Empire is under threat. The engineers have called upon Johed, the mech-powered hero, known for his strength and resilience. Today, instead of fighting enemies, Johed must prove his worth by supporting loads in a mechanical trial, like a beam under stress. Johed is being evaluated by the Grand Engineer Council. He is modeled as a steel beam with a circular cross-section, representing his powerful arm. The council applies a point load of 13 kN at end his shoulder joint, and a uniform distributed load of 7 kN per meter along part of his arm. The circular cross-section has a diameter of 5 millimeters. Your task is to determine the maximum bending stress that Johed's arm will experience. Let's start our solution.
First is we will get the resultant. So to get the resultant, total distance multiply by distributive load. So 7 times 6 is equals to 42. Next is mag-get na tayo sa tong reactions. So moment A equals 0, positive counterclockwise. So By times 2 minus 42, which is our resultant, times 3 plus 5 minus 13 times 6 was 0. So shift solve is equals to By 99.5 upward. So this is our RB, 99.5 upward. Next is summation. So positive upward. So 99.5 is ang result sa reaction A plus RA minus 42 minus 13 is equals 0. Shift solve, RA is equals to negative 44.5. So na negative ni siya kay up downward. So this is our reactions downward.
So the next step is to draw for the shear diagram and the moment diagram. First, we'll go to shear diagrams. The next thing is you will notice on every reactions and loads on your beam. So here we have a distributed load of 7 kilonewton per meter and point load going downward of 13 kilonewtons and a moment reaction here at point C of 5 kilonewton per meter and roller support reaction going upward of 99.5 reaction, and on the hinge we have going downward of 44.5 kilonewton. At this point, at A, we have a 44.5 kilonewton load going downward. Next is the negative 44.5 minus the 7 kilonewton distributed load times its length from A to B, which is negative 48.5. you notice we have going upward reaction, load reaction of roller support. Negative 58.5 plus 99.5. It's negative 58.5 plus 41, positive 41. Next is 41, again 7 kilonewton times 2 minus 7 times 2, 27. And again 27 minus 7 times 1, that's 2. We have 13, and then going downward load or point load 13, which equals 20 on our shear diagram. Okay, now let's practice this to close this diagram from here to here, going here, and to close this to 0. This is a negative shear, positive shear, and another positive shear. That's it for our shear diagram. So the next step is to draw for the moment diagram. From the shear diagram, we will use this as a reference para sa atong moment diagram. Start sa point A, 0 moment lang siya. Tapos, moment, remember that para magkwatag moment is moment plus area from our shear. So, area from A to B is 1/2 base times height. Height nga 44.5 and negative 58.5 since trapezoidal. And if ato siya i-calculate, makakwatag negative 103 na moment. Next is negative 103 nga moment plus again trapezoidal 1/2 base at 2 times plus height times height na 41 and 27, makakuha tao negative 35 na moment. And natin counterclockwise here sa 5 kN per meter na moment sa C, which mag-add na siya, mahimo na siya 40, negative 40 since counter gani negative to siya. Then again same process, negative 40 nga moment plus kay plus man itong shear din 1/2 base na 2 times height nga 27 and 13, mag 0 ang atong shear to close the diagram. And for the shear for the diagram ato na siya ito determine our maximum moment is mo ni siya ang atong maximum moment, which we will use later to solve for our maximum bending stress.
Going back to our problem, which is we are asked to find the maximum bending stress, we will use the formula mc over I. The value of C will be from the centroidal distance of our circular section going to the outermost fiber. And our moment of inertia will be from the formula pi r to the 4th over 4, or simply plug in the radius of 2.5 from 5 millimeters. We will have our value of moment of inertia in our circular section, which is 625 over 64 pi millimeter to the 4th. And now, para makomplete na to plug in ang tanan values, we will refer from our moment diagram. We have the negative 103 as the highest bending moment. So, we will use this as our moment here in our formula. Multiplied by 1000 squared from conversion factor and C of 2.5 over moment of inertia we will have our answer negative 8393195.075 megapascal. That's it. Thank you for listening. In the world of Mobile Legends, strength wins in battles, but in the world of engineering, it's all about stress and solid calculations. So next time you play Mobile Legends, remember, every hero has mechanics, and every beam has its limits. Mechanics of deformable bodies.